everybody got to do.
3.3, we have learned how to find the slope of a line. We've learned how to fill out a table and draw a graph. We've learned how to find x and y intercepts. Now we're going to learn how to graph straight from the equation. And we're going to do it from a form called slope-intercept form. So this is what it looks like. Y equals mx plus b. Alright, y is the y coordinate, x is the x coordinate, nothing tricky there. When we're writing equations, those aren't going to be numbers. They're just going to be y and x. So we're going to have y equals some number times x plus some number. So let's talk about what m and b mean. M is the slope and b is the y-intercept. So we've already learned how to find slope and we've already learned how to find y-intercept. So when we write an equation, we're going to put y equals the slope times x plus whatever the y-intercept is. Right? And there's lots of different forms of equations. We are going to look at slope-intercept form and slope-intercept form only, because for us it's the most useful. We can quickly see the slope and the y-intercept. If I look at an equation, I know whatever number's next to x, that's my slope. Whatever number's added or subtracted to the end, that's my y-intercept. I don't have to do any math. I can just look and see. It's ready to be entered into the calculator because y is by itself. It's y equals, and that's the format we need for the calculator, and it's really easy to graph lines that are in slope-intercept form. So when we graph lines, it's 3 simple steps. The first one sometimes might be done for you, but sometimes you may have to solve for y. So we have to get y by itself. Little hints in there, box the y, move the x, divide. We'll talk about that as we work through some examples. Then we're going to graph the y-intercept. So we're going to plot that point first and use the slope to count to the next points. Alright, so here they don't give us an equation, but they give us some information. We have a slope of 2 and a y-intercept of 4. And we need to write that in slope-intercept form. So here's the form, y equals mx plus b. Alright, remember m right here is the slope. So in this equation, my slope is 2. So I'm going to have y equals 2x because the slope is 2. So I just replace the m with a 2. Then the y-intercept is 4, so my equation is going to be y equals 2x plus 4. Alright, so here's the equation. We already have y by itself, so step 1 of our steps here is already done. Solve for y, that's done. Now we have to graph the y-intercept. So here's my y-intercept is 4, so I'm going to take my pen. I'm going to graph on the y-axis 4. Alright, so my y-intercept is 4. And then we use the slope. Remember, slope is rise over run. So if I have just a 2 here, I have a slope of 2 over 1, because that gives me a fraction, and it's easier to do slope from fractions. So my slope is 2 over 1. That's the rise, this is the run. So that means I have to go up 2, and it's off the graph, but that's okay, over 1. So my next point on this line would be over here. Alright, now we can also, so remember we said this is a positive 2, so that means I go up, okay, and a positive 1 means I go right. If that goes too far off the graph, we can also reverse the direction of both of these. So if I went down 2 and left 1, that would be the same thing, because think about it, down would mean negative 2. Alright, and left would mean negative 1. Well, negative 2 divided by negative 1 is positive 2. So these are the same thing. So I can go the opposite direction as well to get some more points. So I can go down 2, left 1. Down 2, left 1. And now I have a series of points and I can draw my line. And this is going to be really ugly because it's hard to draw a straight line on here. But you will have a ruler and do it perfectly. And there's that line, y equals 2x plus 4. Here we have another example. So this time we have a slope of negative 5 and a y-intercept of 3. So again, I'm going to replace m with negative 5 because that's my slope. And then I'm going to put plus 3 where b is because my y-intercept is 3. So y equals negative 5x plus 3. Then we need to graph. So start with the y-intercept. So the first point I'm going to graph is 3. So on the y-axis I'm going to go up to 3. Alright, and then my slope is negative 5. So remember, if it's a whole number, I'm going to put it over 1. So this is my rise, so I'm going to go down 5, and then my run is over 1. So down 5, 1, 2, 3, 4, 5, over 1. down 5, 1, 2, 3. I'm just going to pretend for 5 over 1. And there's my line. And I just draw it down. And there we go. It's that easy. Alright, sometimes you're going to have to solve for y. You're going to have to get y by itself. So here are some examples here. If we were going to write these in slope-intercept form, I need them to be in the form y equals mx plus b. So I have to get y by itself. So if we look back at the steps, I gave you some hints. Box the y, move the x, and then divide. These steps should work every time for getting a line in slope-intercept form. So if we look at example 3, first thing I'm going to do is I'm going to box my y, because I know that's what I'm trying to get by itself. So now I have to move the x to the other side, because I want y by itself. Well, if I'm moving something from one side to the other, I always have to do the opposite. So I have negative 4x over here. I'm going to add 4x, all right, to both sides. Alright, when I do that, I have y equals left on this side, and over here I would have 2 plus 4x. Now, this is fine, but if we look at our slope-intercept form, it has the mx part first. Okay, so I'm going to go ahead and reverse these and make it 4 plus 4x plus 2. Alright, 4x plus 2. Let me clean that up. Alright, y equals 4x plus 2. These are the same thing. Remember, addition is commutative. I can change the order that I'm adding things and it doesn't change my equation. So I'm going to put the mx part first because that's what it looks like in my slope-intercept form. Okay? I want you to, let's do number 4 as well. So first thing I'm going to do is I'm going to box my y. So that's what I'm trying to get by itself right there. Okay, so I need to move this 3x to the other side. And remember, to move, we always have to do the opposite. So it's minus 3x, so I'm going to do plus 3x on both sides. So now on the left side I have 7y, and that's going to be equal to 3x plus 21. I went ahead and put the mx part first, so I match slope-intercept form. Last step is going to be to divide by 7. And remember when we did literal equations, and I told you had to get used to dividing every term by 7? This is why, because when you're putting things in slope-intercept form, you have to divide the mx part by 7, and the b part. You have to divide everything by 7. So when we do that, 7y divided by 7 is just y, 3x over 7. I'm going to simplify, if I can, this fraction, but 3 over 7 can't be simplified any further than that, so I have 3/7 times x, and then 21 divided by 7 is 3, so I have plus 3. Alright, I want you to pause here and try number 5. So your final answer should have been y equals 3/2 or 3 over 2x minus 4. If you didn't get that, put a circle around that one so you can ask about it in class. Here's the next example. So negative 4x plus y equals 2, and we would need to graph this. So again, first thing I have to do is get the y by itself. So I'm going to box my y. I got to move my x. So I'm going to add 4x to both sides, and then I have y equals 4x plus 2. I don't have to divide anything here because the coefficient of y is 1, so we're good to go. We're ready to graph. Alright, first thing I got to do is graph my y-intercept. So it's 2, so I'm going to go to 2 on the y-axis. There's my first point. Then we need the slope. Remember, if it's a whole number, we're going to put it over 1. So 4 over 1. I'm going to go up 4. Alright, and right 1. Or I can go down 4 and left 1. We can always reverse the direction. So if I go up 4, that's going to take me off the graph, but that's okay. 1, 2, 3, 4 over 1. And then I can also go down 4, 1, 2, 3, 4, and left 1. And there are 3 points that I can connect. And you will do it in a perfectly straight line. So please excuse my crooked ones. Alright, you're going to do this one by yourself. So pause here, do number 6. We'll go over it in class. Last topic we need to talk about is vertical and horizontal lines. So these are the special cases that we talked about a little bit before. VUX and HOI are just kind of mnemonic devices to help you remember things. So if I have a vertical line, it has an undefined slope, and the equation is going to be x equals some number. So there won't be a y equals. It won't be in slope-intercept form. It will just be x equals 4 or x equals negative 7. That's a vertical line. If I have a horizontal line, it has a slope of 0, and the equation is y equals some number. So again, not slope-intercept form. There's no mx. It's just y equals 7, y equals 2. all right? Or we can remember the little face. If it's a vertical line, the equation would be x equals 2, x equals some number over here, and then it's an undefined slope. Remember, that's what that is. And then if it's a horizontal line, it's y equals -3 or some other number, and the slope is 0. So here's some examples and how we draw these. So x equals 3, I know that's going to be a vertical line, all right, so straight up and down, and it's at 3. So if I go to 3 on the x-axis, and it's a straight up and down vertical line that goes through x equals 3. All right, same thing for a horizontal line. If it's y equals 2, I know it's straight across, and it's y, so I'm going to 2 on the y-axis this time, and I'm drawing a straight across line that goes right through that point. Okay, so those are easy. You just have to remember which direction to go. All right, if it's x, go to the x-axis. If it's y, go to the y-axis. All right, you have some more examples. See if you can draw those vertical and horizontal lines, and then we'll see you in class.